My name is Kyle Templin.
My name is Amit-Kyle, and this is our project on Mars, the next frontier. NASA has a vast array of different missions addressed at Mars. One of its most predominantly successful missions has been Spirit, one of NASA's Mars exploration rovers. Unfortunately, since May 6 of 2009, the rover has been trapped hub deep in the Martian soil, with only 4 out of its 6 wheels fully functional. At its current position, the solar panels used to generate energy and electricity for the rover is facing away from the sun. During the Martian winter, the sun predominantly remains in the northern sky. As of February 8, 2010, Spirit has been officially parked for the winter, with its solar panels tilted 9 degrees to the south. So what does this mean for Spirit and its future activities on Mars? As of now, NASA has reduced most of its communication activities to a bare minimum. It is expected to track its radio signal through space. Scientists believe that since it is stationary, any motion of the signal would in fact be that of Mars as well. By using this information, scientists will be able to calculate its rotational wobble and if the core is solid or liquid. What scientists are hoping to calculate is a term that they refer to as MOI, or the moment of inertia. It is described as a number that tells us how easy or how hard it is to change the spin or wobble of a planet. Bruce Bannard of NASA's Jet Propulsion Laboratory says, "The moment of inertia affects the speed at which the axis of Mars wobbles. So the wobble speed indirectly tells us the MOI. After calculating the MOI, scientists will use that information in addition to data that we already know about Mars, such as planet size, planet mass, the behavior of iron and rock, and this will help tell us the size and density of the core." What exactly would this mean? Well, this would mean we would have greater insight into what other materials are present in the core, which in turn, as Squires, the principal investigator of the Mars exploration program, tells us, if Mars's core is solid through and through, the nature of the wobble will be subtly different from the wobble of the core if the core is liquid. What are the implications of all these research? This research has implications that reverberate through all kinds of basic questions about the formation of the solar system and its planets. It can reveal similarities between Mars and Earth that we may not know and that we already do. Observations point to a habitable and life-sustaining Mars at one point in its ancient history. These data can also help us better understand the fundamental planetary processes that exist in the development of solar systems across galaxies.
So if Mars is so similar to Earth, then why is it so different at the same time? Well, a theory has been presented that dates back to the late heavy bombardment period. The late heavy bombardment period, or LHB, occurred between 4.1 and 3.9 billion years ago. Evidence of large amounts of cratering on Earth, the Moon, and Mars, and by inference Mercury and Venus, all experienced heavy bombardment. This bombardment was potentially caused by gas giant migration in the outer solar system. That's where Jupiter and Saturn were disturbed enough to dissipate a trans-Neptunian belt made up of numerous minor planets similar in nature to Pluto. It is believed that during this period the Borealis Basin on Mars was formed. It's the largest known impact crater in the solar system and was discovered by NASA's Mars Reconnaissance Orbiter and Mars Global Surveyor. The Borealis Basin covers 40% of the Martian surface and is estimated that the object that made the impact was estimated at 1,200 miles across. That's larger than Pluto and 200 times the size of the asteroid that caused the KT extinction event. It caused the mass extinction of dinosaurs on Earth. The pictures on the right depict the sheer massive size of the crater. Scientists didn't see it at first because of its huge size and the fact that millions of years of volcanic activity around the rim obscured its obvious circular shape. With the help of the orbiter, it was finally discovered. So what are the effects of the impacts on Mars during the LHB? Well, data from studying these impact craters reveals the presence of magnetism. Magnetism may suggest that Mars, like Earth, had a healthy, functioning magnetosphere propagating a core dynamo in its early life. UC Berkeley scientists have linked age estimates of impact basins with magnetic field strength, and they found that 500 million years into Mars's life, 3.9 billion years ago, its global magnetosphere disappeared.
And then
it would make sense that during this time Mars's dynamo died, but even though the Earth suffered similar impacts, it has a 2 times bigger radius and 10 times the mass of Mars, and would have had a much stronger dynamo able to survive these kind of events. Pictured below is a reading of Mars' crustal magnetism by the Mars Global Surveyor. You can see that there is an absence of a global magnetosphere with only small pockets of magnetism. In order to test the correlation between the impacts and the disappearance of Mars' magnetosphere, the Berkeley scientists then modeled the heat released in these large impacts and what their potential effect on the mantle convection could be. It was found that through the enormous amount of heat released by these, the mantle was changed to a kind of heating pad instead of an ice pack. This extra heat was enough to stop the core convection. Without the convection, Mars' dynamo would have been unable to sustain a global magnetosphere, which drastically impacted the planet's future evolution.
Documented in the picture below is the process of core convection. This phenomenon exists not only in Mars but also on Earth. The mantle around the planet's core is slowly dissipates the heat toward the surface, being cooled, and in turn the cooler mantle from the top layers are recirculated back into the mantle towards the core. So what are the astrobiological effects of a magnetosphere? The magnetosphere acts primarily as a planetary shield. Without this shield, streams of ionizing particles, more commonly known as ultraviolet radiation, can be spewing from the sun and strip away a planet's atmosphere. The effects of this could include vaporization of any water on the surface and the killing of all surface life or forcing it underground. Spirit's success can also be seen in other projects. In May of 2007, Spirit crossed paths with a patch of soil that was rich in silica, almost 90% pure. Scientists were stunned to find this composition among the soil because in order for silica to form, the presence of water is required. Albert Yen of NASA's Jet Propulsion Laboratory was quoted, "This is some of the best evidence Spirit has found for water at Gusev." This patch of soil was discovered as the non-functional wheels of Spirit are slowly dragged along the Martian surface, slowly churning up layers of soil from beneath the topsoil. This has immense implications as well, as it is evidence that suggests that ancient Mars may have been capable of supporting life. Understanding Mars's history can provide insight into our continued search for life in the universe and also provide us with new techniques and methods that can be utilized to discover life among our universe as well. Spirit has had a long and successful journey. It started out with a 3-month mission and has survived for nearly 6 years, although it is showing signs of age. It has helped scientists uncover secrets to Mars that no one thought possible, that could potentially enable us to create an artificial ecosystem on Mars. Mars has always been considered Earth's twin, a place where life seems only naturally possible. All these studies have only brought us one step closer to understanding Mars's nature and what it would mean for life for humans.
They say them boys hustlers, them hoolums though. Get that money, man. Get that money, man. Get that money, yo. I gotta get that money, man. I gotta stack cheese. I gotta stack cheese. I need at least 2 G's in my khakis. Get that money, man. Get that money, man. Get that money, yo. I gotta get that money, man. I gotta stack cheese. I gotta stack cheese. I need at least 2 G's in my khakis.